Hello, in this video, we are going to be looking at a concept called the nth term. And more specifically, what we're going to do is we are going to use the nth term to help us solve some complex number sequence problems. Okay, so let's have a look at the screen. Okay, so the nth term. On my screen, I have a sequence, okay? And I can see the sequence is going up in 4. Look, 3, 7, 11, 15. I can see the sequence is going up by 4 every time. But what is a challenging question is, well, what would the 100th number in that sequence be? And rather than sit there and say, well, 3, 7, 11, 15, 19, 23, 27, that's going to take you too long. Okay. And not only that, but you might make some mistakes along the way, which means your answer is going to be wrong. So what we could do is we can use something called the nth term to write an expression for this sequence so that we're able to quickly discover what the 100th number in the sequence is. So let me show you how this works. Firstly, I'm going to write n up here, and I'm going to write t down here. Now, n is the position of each number in the sequence. So 3 is the first number in the sequence, 7 is the second number, 11 is the third number, and 15 is the fourth number. So far, very straightforward. I'm just writing 1 to 4 to show the position of each term in the sequence. Okay, now what I need to do is I need to work out the difference between each number. So how is this sequence progressing? And we have already spoken about this. It's going up in 4. So I simply write 4, and I'm going to follow it with n. So I've got 4n as the first part of my expression. Now, to complete this expression, what I need to ask myself is, if my sequence 3, 7, 11, 15, if that sequence had started one number earlier, what number would that be? And the way to find this out is, because the sequence is going up in 4, I just need to subtract 4 from the first number in the sequence. So 3 subtract 4 is -1. So I'm literally writing -1 out into the expression. And my expression is now 4n subtract 1. Okay, so I can use this expression to find any number in that sequence. First of all, before we find the 100th number, let's just prove that this expression works. If I look at the third number in this sequence, okay, what I need to do with my expression is do 4 multiplied by n, which in this case is 3. So 4 times 3 is 12, subtract 1 is 11. So I can see that my expression has worked. Let me just make sure by looking at the second term. 4 multiplied by n, in this case is 4 multiplied by 2 is 8, subtract 1 is 7. So I know that my expression works for this sequence. So to find the 100th number in the sequence, all I need to do is replace n with 100. 4 times 100 is 400. Subtract 1 is 399. So that is the 100th number in my sequence. Now let's do it again. First thing I need to do is write n and then write t. T are my terms. They are already written there, 1, 4, 7, and 10. And n is the number in the sequence that each number appears. So number 1 is the first number in the sequence, number 4 is the second, number 7 is the third, and number 10 is the fourth number in the sequence. Okay, so first step is, how is this sequence progressing? Now the sequence is progressing, it's going up by 3 every single time, isn't it? It's going up by 3. So that's the first number of my expression. I then need to follow that with an n. And then I ask myself, what number would have started this sequence had the sequence started one number earlier? So I just need to subtract 3 from the first number, which would give me -2. So my expression is 3n subtract 2. Okay, and now make sure it works. Let's use the second term. So 3 times 2 is 6, subtract 2 is 4. Let's use the fourth one. 3 times 4 is 12, subtract 2 is 10. So I know my expression works. So to find the 100th number, let's replace n with 100. 3 times 100 is 300, subtract 2 is 298. So I know that the 100th number in the sequence is 298. Okay, so far we have looked at sequences that progress. We've looked at sequences that go up. All right, so the first sequence went up by 4, The second sequence went up by 3. But what if our sequence goes down? What if it declines in value? Well, not much changes at all. Let's go through it. So once again, I start by writing n, and then I write t. First number in the sequence is 7, second is 4, third is 1, and 4 is minus 2. Okay, first step is to find out the difference between these numbers. Now, this is an important bit. These numbers are decreasing by 3. They're not going up by 3 this time, they're decreasing by 3. So I have to show that in my expression. I must be clear. So minus 3n. And then, once again, I ask myself which number would have come first in this sequence had the sequence started one number earlier. So I just now need to add 3 to the first number, which is 10. So my expression is 3n plus 10. And the reason it's plus 10, the reason it's add 10 is because this 10 is a positive number. It's not below 0, it's a positive 10. So I must show that in my expression. So my expression is negative 3n plus 10. Let's see if it works. Let's use the third term. So let's replace n with 3. So minus 3 times 3. Okay, when we're multiplying a minus number, it's just the same as multiplying a positive number, isn't it? Okay, so so 3 times 3 would be 9. So minus 3 times 3 would be minus 9. Okay, so minus 3 times 3 is minus 9. Minus 9 plus 10 gives me 1. So I know that's correct. I know that my expression works. So let's find the 100th number in the sequence. Let's replace n with 100. So minus 3 times 100 is minus 300. So let me write that number down, minus 300. Now I need to add 10 to minus 300. So minus 300 plus 10 is minus 290. Remember, the answer isn't minus 310 because when we add numbers to a negative number, we need to get closer to 0. Okay, so the 100th number in the sequence is negative 290. Okay, now this is why the nth term is very, very useful, because if I had sat there and counted up 3 from 7, or sorry, down 3 from 7 all the way to the 100th number in the sequence, that's going to take me a very long time. And I might make mistakes along the way and my answer won't be right. Okay, so that's why it's very useful to find this expression. Okay, let's do one more. Let's do one more. So firstly, n. Secondly, t. 40 is the first number in the sequence. This is the second one. This is the third one. And this is the fourth one. Okay, first step is what's going on in this sequence. How is the sequence changing? And we can see that it's going down by 10 every time. It's being decreased by 10. So I must write that in my expression, minus 10, followed by n. And then I ask myself, well, what number would have started this sequence had this sequence started one number earlier? So all I need to do is add 10, okay, which is 50. And it's a positive 50, isn't it? It's above 0, that 50. It's not minus 50, it's a positive 50. So I have to show that in my expression. So my expression is negative 10n plus 50. Okay, so let's check to see if it works. Let's replace n with 1. Minus 10 times 1 is still going to be minus 10. Minus 10 plus 50 would give me 40. So I know my expression works. Okay, so hopefully this has been clear. It's not the easiest thing to do at all. So you might need to rewatch this, you might need to pause or rewind certain bits, but when you're feeling confident, have a go at solving this. So can you write the expression for the nth term for each sequence? And then when you've found the expression, can you find the 100th? I don't know that word digit. Can you find the 100th value or number for each sequence? Okay, so find the expression for each sequence, then find the 100th number for each sequence. Okay, thank you very much for watching. Goodbye.